Hello, welcome one and all. Today this meetup is for the presentation of our Samuel bike sharing demand prediction capstone project. It is a capstone project that is the project type is the regression, and this is project is completed by me myself Kiran, and it is a individual contribution for the project. Now let's talk about the project. The project name is the Samuel bike sharing prediction. That is the Seoul is the name of a city. That is the in that city we have the data of that cities, and from this data we have to make the predictions for the demand for the sharing bikes, or we can say for the rental bikes. Now come to the technical parts of the project. In our data set, we have about 8,760 rows, and number of columns are there 14. The different columns, that is the we can say features, you can see here. These are the different features, or we can say variables, or that is the columns are in our data set, and our target variable, or we can say that is the dependent variable, or the target feature is the rented bike count. Now, as some EDA work is processed over the file, or data set, after that we came to know that the number of rows are this much, and the number of columns are 14, and the 14 columns are have different data types. The values, or the information stored in 14 columns, is of different data types, and out of that 14 data types, all data types have the numeric data, except four variables, or except four columns, that namely data, that column is data, season, uh, functioning day, right? This is day, yeah? Something spelling mistake is here. These are the four variables or columns only which have the data in the form of object, and except these four columns, all columns have the data in the form of numeric. Now, after doing some or doing some code, we came to know that there are no null values in the dataset. Also, there were no any duplicate values have been found. And as we run the correlation matrix, we came to know that some features, that is the temperature, dew point temperature, solar radiation, and visibility, and wind speed. These variables are of prime importance, because as or these variables are much more dependencies shows for the our target variable, means our target variable is much more dependent on these variables. Okay, now let's go to the further part of the project. Here we have imported some libraries for the various purposes, or for doing various functions. For example, pandas. Then we have imported numpy. Then we have imported matplotlib. Right? These are the different libraries, and then we have imported cboard. Basically, MATLAB and cboard. These were two libraries have been imported for the visualization purpose. Then some preprocessing modules, for example, min-max scaler, then one hot coding, then multilab linear. These are the different packages we have imported. Then we have implemented some module, some algorithms, some, or we can say machine learning modules, namely linear regression, lasso, reach, elastic net, decision tree, random forest, gradient boosting, boosting regressor. These are the model machine learning models that we have implemented here, and this is the code for the import of these modules or models. Now further look at the data sets. This is the code by which we have mounted our drive, that is the Google Drive, to our Column notebook, to make the dataset file accessible for doing the analysis work. Now let's get know about the data. The data set file. Here we can see the dataset file is stored with the name as BKDF. That is the it is the abbreviated form for the bike data frame. Bike data frame. Now to get know about the data, we have run code here. For example, a dot head to see our data, then dot tail, then dot sample, right? That is the this dot sample is for the this function is used to get some samples from the our data frame, and randomly we have got these five samples, right? These are the this first column is nothing but the that particular row number of the data frame. Then about the shape of the data frame. From that we came to know that we have a data frame which is having 8760 rows and 14 columns. Then get know about the information of the data set. From here we get know that these are the columns name, right? This column name shows the different columns, or we can say variables, or we can say features, right? And these features are of non-null count, right? Means in every column we can see there is a that is the 8716 null values. Means there is no any null value in the data set. And in the last column, that is the d type, this is the data type of that particular column. Now n unique values, this is to get know that how unique values are present in our individual column. Now a description about the data set. These are the this is the description of our columns, right? And that is the breakdown or of our variables or features, or that is we can say columns, variables or features. And namely there are different columns, that is the rented by count. Obviously it is that is the number, or it is the count of bikes of a bike on that particular day have demand, or there is a that bike is went on rent. Then hour, that is the at which time of the day, that is we consider a day of 24 hours, and in that day in that day at which hour the bike is went on rent. Then temperature, it is self-explanatory columns, that is the temperature, humidity, wind speed, visibility, dew point temperature, then solar radiation, then rainfall, snowfall, season, right? Then holiday, is that a day is a holiday or no, right? These are the categorical information. Then season is also a categorical information, that is the four seasons are there. Hmm. Then functioning day, that is the it is also categorical type of data, that is the is it functioning day, yes or no. These are the two categories in that column. Then is null. This is to check if there are any null values present in a our data set, and here we can see in any of the column there is no any null value present. Then check for the duplicated values, and there we found that there is no any duplicate value present in our data. Now we have changed some data types. That is the we have that categorical data, that is the object type data, and there were different categories, and we have to change it for the further necessary analysis work. We have to make changes in the data type of that some columns in the data set. Here you can see that is these are the at last column. These are the data types mentioned. Then about the exploratory data analysis. Okay, now about the exploratory data analysis of the data frame or data set. First, that is the count of rented bikes in a respective month. That is the month-wise count for bikes. We can see here. This is the bar chart we have plotted here, and here you can see 12 different months are there, and according to this bar chart we can say that in the month 6, that is the sixth month, have the most or the highest counts for the rented bike, and it is approximately we can say that is the 1300 counts have been observed for the sixth month for the rented bikes, and the then we can say that from this bar chart, that is the from month 5th to month 10th, right? From month 5th to month 10, uh, there is a maximum demand for the rented bikes, right? There is a maximum, obviously we can say approximately it is 900 to 1000 count we can observe for this month 5th, 6th, 7th, 8th, 9th, and 10th. Then the list count is observed for the month of first month, second month, and then we can say 12th month, right? Means from the month 10 we can say there is a recession, right? From the month 10 we can observe, or not from 10th but the from 11th, right? After 11th there is a recession period for the rented bikes. That is the then the 12th month, then first month, and then the second month. These 3 months will have recession for the demand for rented bikes, right? And from third month, there is again a succession in the count or in the demand. There is increasing demand. Okay, now this is the chart to show the count of rental bikes according to the weekdays and weekend days. And from this, we can say that at the weekend, that is the one means that is the weekend days. Weekend days have been observed with less count as compared to the working days or weekdays, right? And it may be due to as weekend days consist of only Sunday and Saturday. Only 2 days are consisted in the weekend column, right? But the weekdays, right? This blue bar. uh, it is a count of 5 working days, right? And maybe that is why this count may be higher than the weekend days. Then this is the plot or point plot to show the count of rented bikes according to hour, right? According to hours, that is the hour, each day is distributed in 24 hours, right? Accordingly, that we have made this point plot, and here we can say that at the 8 a.m., right? At we can say at 8 a.m. there is a maximum demand or the peak demand. It may be due to office timings, right? Maybe due to office timing, or people use this sharing bikes to go for the offices. And same at the evening time, or we can say at 6 p.m., right? There is again maximum demand for the sharing bikes, and it also may be due to the office timings shut off of the offices, and people use maybe using rented bikes to went to home from the offices, and that is why these two peaks may be observed. One peak is at morning, and the second peak is at the evening, 6 p.m. Okay, we have to make or we have to finish this presentation within 25 minutes, and that is why, and maybe that off, I may skip some part of the EDA or some part of the collab, right? But you will be accessible with the collab link. Now this is the bar plot for the count of rental bikes according to functioning day. It is a spelling mistake. Sorry for that. Now, according to the functioning day, we can say on the functioning day that is maximum count is observed. That is, we can say about 700 or 710 or 20. And on non-functioning day, there is no demand count have been observed. Then count of rented bikes according to the season of the year. As previously we know that there are 4 seasons in a week, and in that 4 seasons, the summer season, right here, that is the green bar, the 4 seasons have been observed with maximum or the highest demand for the sharing bikes, and the count in the summer season is observed of approximately 1000 in that particular season, and then followed by the season autumn for the demand sharing, right? um, that is the approximately more than 800 we can say, and then followed by spring season shows a demand approximately around 750, right? And the list demand is observed for the season of winter, and it may be due to there may be rainfall, there may be snowfall, or there may be less visibility, right? These are the anti-correlated features for the rented bike count, right? And that is why in the winter season there is a list demand. We have observed list demand. Then analysis of numerical variables. Now let's jump to the model parts. For the case of algorithms or machine learning algorithms, we have performed several several algorithms, right? Mm, Before that, let's discuss about the correlation heat map for the parameters, right? From this correlation heat map, we can say that the highest correlation we can observe for the our rented bike, that is the our target feature or target variable. For that, the highest or the maximum correlation is found with temperature, right? Temperature, then followed by dew point temperature, then followed by solar radiation, and then followed by the we can say it is visibility, right? Mm. These are the highest or highly correlated factors, right? And then the list related variables or features, we can say that is the humidity, then there is rainfall, snowfall, right? These are the anti-related or list correlated variables, and that is why there is, and that is why we have observed list demand for the sharing bikes in the season of winter. Now go to the part of machine learning algorithms. Here we have performed some one hot encoding, then some model training. We have taken a data and split it into uh, time is running out, and split it into training set and testing set. And then after splitting data into training set and training and testing data sets, we have performed five machine learning algorithms. Here we can say, you can see that we have results of these five machine learning algorithms. We have performed five machine learning algorithms, namely first one is the linear regression, then we have performed lasso regression, then we have performed ridge regression, then we have performed random forest regression, then we have performed gradient boosting regression, right? And on both, that is the training data set and on testing data set, on both data sets we have performed these five uh, algorithms. And after performing these five algorithms, we came to know that, or from the evaluation matrices, by performing the evaluation matrices, we can say that it is observed that uh, the random forest regression and gradient boosting regression are the well performer or the good performers, right? Because here we can say that the mean absolute error or mean absolute error, mean square error, random mean square error, these error values are list observed in the random forest and in gradient boosting, right? It is also and for both the cases, that is for training data set also and for the case of testing data set also. And the good score, we can say that is this good score or the R score values for the random forest is also very high, or as we can say, if R square value is as high as that would be more good for the model or for the our implementation, because it gives good result. And for our random forest, R square value is also very good, and the for the gradient boosting also the R square value is very good. And from this we can say that this we can say that among all these five models, the random forest regression and the gradient boosting regression, these two are the best performers, are the best performer. And among these two models, uh, the random forest model uh, is found good or a better choice uh, than the gradient boosting regression, right? And why? Because here we can say that the mean square or the error values for the random forest are less than the gradient boosting, right? And the R square values, and the R square values is high. R square value is high of random forest than the gradient boosting. That is why we can recommend random forest regression model to predict the bike sharing for the demand, for its demand for in the civil city. Okay. Uh, okay, thank you. As time is running out, all other necessary part would you have with this colloquial book. Thank you. You can access it.